Hi students. Actually, this is also continuation of Lewis dot structure. In the last two videos also I have discussed how to write the Lewis dot structure for the molecules, some of the molecules and ions. But I thought those videos are not sufficient according to your examination point of view. So I have picked up some more examples where you will definitely face a problem while writing the Lewis dot structures. So today we'll discuss those examples. By this we can complete this Lewis dot structures. Definitely after watching this video, you can write a Lewis dot structure for any molecules. If you didn't watch my previous videos, I will provide the link in the description. You watch those two videos also, then you will get a clear idea how to write the Lewis dot structure. Okay, now I will discuss some examples. That those are SO3 and SO3 2 minus, here it is SO4 2 minus and SO5 2 minus. For these we'll discuss how to write the Lewis dot structures. Okay, so as usually you follow the same procedure for writing the Lewis dot structures starting from the sulfur trioxide. We'll start with the SO3. Okay. So here as usual, here before entering into this topic, I would like to discuss one of the important point. Here why sulfur shows variable valency. Here sulfur exhibits valency 2, 4, 6. Why this sulfur? This is one of the previous question also. The reason why sulfur exhibits variable valency 2, 4, 6. What is the reason? Before discussing the Lewis dot structure for these ions, first we will discuss this one, why sulfur exhibits variable valency. So here first write the electronic configuration of sulfur. Sulfur with an atomic number Z. Now write the electronic configuration. It is 1s2, 2s2, 2p6, 10. It is 16. So 3s2, 3p4 and empty d orbital also there. So 6 plus 4, 10, 16. So here write down the 1, 2, 3, here fourth one. Here there is an empty d orbital. Okay. So here it is ground state. Ground state electronic configuration of sulfur. This is ground state electronic configuration of sulfur which exhibits a valency of 2. Okay, so first excited state. Star means excited state, first excited state. So here in the first excited state, this electron will jump into this vacant d orbital. Now write down the electronic configuration. One, two, three. This electron. So what is the valency here? It exhibits the valency of 4. Okay. Now here second excited state of sulfur. So in the second excited state, this electron will jump into this orbital. Now write down the electronic configuration. Now the valency is 6 for this one. So here what is the reason why sulfur is exhibiting variable valencies? Because of the vacant d orbitals. Remember, this is one of the question, previously asked question. So here why sulfur is exhibiting variable valencies. So before writing the Lewis dot structure for this for the sulfur containing molecules or the ions, you should know this point, sulfur. And also one more point I would like to add here, the central atom, whatever while writing the Lewis dot structures, the central atom will be in, means here it tries to be in maximum covalency. The central atom tries to be in maximum covalency. So here sulfur, it exhibits a variable valency, and here maximum covalency means 6. Remember this point. And here I have discussed another point also, why sulfur is exhibiting variable valencies. Here this is because of the vacant, this is because of the vacant d orbitals. Clear? Okay. Now we'll get into the topic. Now here I have taken SO3 molecules. As usually you write whatever the steps I have discussed in the previous videos, you follow that procedure. So here first one, valence electrons. Here how many valence electrons are there? Sulfur belongs to 6th group, and here oxygen also belongs to same group. So 3 6 are 18. So 6 plus 18 valence electrons are there. So which is equal to, the valence electrons are 24 valence electrons are there. So now write the skeletal structure for SO3. Here the central atom is sulfur, which is least in count and less electronegative, all the points, etc. So here it is the central atom. Now here write down the step 2. It is step 1 we have completed. Here step 2, here the central atom, around the central atom 3 oxygens. Write down the skeletal structure. Calculate the step 2 bonding electrons. How many bond pair of electrons are there? 2 into number of bonds. Here 2 into number of bonds 3, which is equal to 6 electrons. After writing this, calculating this bond pair of electrons, now step 3, it is calculate the lone pair of electrons, which is equal to 24 minus 6, valence electrons minus 6. So here if you didn't watch my previous videos, please first watch those videos, and after watching those videos this will be clear to you. Okay, lone pair of electrons 24 minus 6, which is equal to 18 electrons. Now you share these 18 electrons, start sharing these 18 electrons to the skeletal structure of this SO3, starting from the corner atom. So 1, 2, 3, 4, 5, 6 and 7, 8 valency of this one, octet of this oxygen is satisfied. Very good. 1, 2, 3, 4, 5, 6, octet of this oxygen also satisfied. 1, 2, 3, 4, 5, 6, octet of this one also satisfied. Now here come to this sulfur. Here it is 1, 2, 3, 4, 5, 6. Here I told you already, central atom tries to be in maximum covalency, but around the central atom sulfur, here what is the maximum covalency? It want to be in that covalent, but around the sulfur there are only 6 electrons. And this oxygen will share a pair of electron, this will share a pair of electron, so this will share a pair of electron. So how many bonds around the sulfur? 1, 2, 3, 4, 5, 6 bonds around the, so the covalency is 6 satisfied. Okay, central atom can have more than 8 electrons. This is the point I want to discuss now through this video. Okay, central atom can exhibit a maximum covalency. So here, now the Lewis dot structure for SO3 is this one. Now write down the lone pairs 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Now one by one, 1, 2, 3, and for this sulfur also you calculate the formal charge. Okay, quick. So first one, O1. What is the formula for formal charge? Formal charge is equal to, here valence electrons minus lone pairs minus 1 by 2 bond pairs, bond pair of electrons. So here how many valence electrons? Oxygen belongs to 6th group, so therefore 6 valence electrons. How many lone pairs? Here 1, 2, 3, 4, 4 lone pair of electrons minus how many bond pair of electrons? 1, 2, 3, 4, 4 by 2, which is equal to 0. And next calculate the formal charge for O2. Here also how many valence electrons? Oxygen belongs to 6th group. Around this oxygen 4 valence electrons and 4 bond pair of electrons. This also 0. And calculate the formal charge for O3, this third oxygen. Number of valence electrons minus 1, 2, 3, 4 lone pairs minus how many bond pairs? 1, 2, 3, 4. 4 by 2, which is equal to 0. No charge. And now for the sulfur also you calculate the formal charge. Sulfur also belongs to 6th group. Both the atoms belongs to the same group, oxygen and sulfur. And valence electrons, 6 valence electrons minus, Here, how many lone pairs? 0 minus how many bond pairs? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 by 2, which is equal to 0. So, here, this is the way of writing Lewis dot structure for sulfur containing compounds or the ions. So here the point which I have added in through this video, the point which you have to remember is central atom tries to be in maximum covalency, and here sulfur exhibits a variable valency. The reason also I have discussed. Because of the vacant d orbitals. So here it want to be in maximum covalency, which is 6. So here calculation of valence electrons, bond pair, after writing the skeletal structure, bond pair of electrons, and the lone pair of electrons, valence electrons minus bond pairs, which are 18 electrons. 18 electrons you start sharing from the corner, but sulfur valency is not satisfied. So here these 3 oxygens will share a pair of electrons, and the here sulfur exhibiting a covalency of 6. So this was satisfied. Now after writing the skeletal structure, you calculate the formal charge. Here any atom with a here formal charge 0 means the molecule is more stable. Okay. Now next we'll discuss another example. Now the next example is SO3 2 minus. Actually this anion is derived from H2SO3 sulfurous acid. So here SO3 2 minus, SO3 2 minus. Now here it is sulfite. It is sulfite. And SO4 2 minus. Next we will discuss this one. And after that SO5 2 minus. This is derived from H2SO4 sulfuric acid, which is sulfate. That is sulfite, and this is SO4 2 minus is sulfate. And here it is peroxy sulfuric acid. This is derived from peroxy sulfuric acid. H2SO4 is sulfuric acid. H2SO3 is sulfurous acid, and it is peroxy sulfuric acid. So here this we call as peroxy sulfate. This anion we call as peroxy sulfate. Okay, it is sulfurous acid. The anion of sulfurous acid is sulfite, and the anion of sulfuric acid is sulfate, and the anion of peroxy sulfuric acid means it is peroxy sulfate. Okay, all these we'll discuss in a separate video, don't worry. I think we have deviated from the topic. SO3 2 minus. This is sulfite. Now, as usually, here calculate the valence electrons. Sulfur belongs to 6th group, plus how many oxygens are there? 3 oxygens are there. Oxygen also belongs to 6th group. 3 6 are 18, and here anion 2 minus. So add 2 electrons to the valence electrons. 18 plus 2 20, 26 valence electrons. Now in the second step, this is the first step. Second step, write down the skeletal structure as usually. Here central atom is sulfur. I told you already how to decide which one is the central atom. Here around the sulfur 3 oxygen atoms. This is the skeletal structure for SO3. And now calculate the bond pair of electrons. Here bond pair of electrons is equal to valence 2 into number of bonds. Here 1 2 3 bonds are there. So which is equal to 6 bond pair of electrons. And next third step is calculation of lone pair of electrons, which is equal to 26 minus 6, which is equal to 20 lone pair of electrons. Okay. 18 plus 2 6 2 into number of bonds, it is 3. Yeah, 26 minus 6 bond pair of electrons. Okay, so here now start sharing these lone pair of electrons starting from the corner atom. So 1 2 3 4 5 6, 1 2 3 4 5 6, here 7 8, octet of this one satisfied, octet of this one satisfied, 1 2 3 4 5 6, octet of this one satisfied, because 2 bond pair of electrons are there, and here 3 6 are 18, and we left with 2 more electrons. So here these 2 more electrons on the sulfur, but here we have this charge. Where to keep this formal, where to keep this charge? Here sulfur, around the sulfur 3 bonds are there, but here sulfur wants to be in maximum covalency. So here 3 bonds means here sulfur exhibits 2 4 6 covalencies. So around the sulfur only 3 bonds are there. So this oxygen will share a pair of electrons with the sulfur. Now write down the skeletal structure for the sulfur as double bond O and 2 lone pair of electrons, and oxygen 1 2 3 4 5 6 around this oxygen, and here around this oxygen also 1 2 3 4 5 6, and with a lone pair. I told you already where to keep the negative charge. Here you calculate the formal charge for each and every atom, that is another story. But here oxygen with a double bond, there is no charge. The trick I have discussed in this second video of Lewis dot structures. So oxygen with a double bond, there will not be a charge. And here 2 minus, where to keep this -1? Maybe here this oxygen, because oxygen with a single bond, oxygen with a single bond, there will be a definitely a negative charge. So here this may bear a negative charge and this may bear a negative charge. For the confirmation you calculate the formal charge. Now calculate the formal charge for each atom including sulfur. So first oxygen atom O1, here calculate the formal charge. Here number of valence electrons minus lone pairs. What is the formula for formal charge? Here formal charge is equal to valence electrons minus lone pair minus 1 by 2 bond pair of electrons. Lone pair of electrons and bond pair of electrons. So 6 minus, how many lone pairs? 1 2 3 4 minus bond pairs 1 2 3 4, 4 by 2. Here I told you 6 minus 6, which is equal to 0. There is no charge on this oxygen. Okay, and you calculate for formal charge for this oxygen, definitely you will get -1. O1, here number of valence electrons 6, because oxygen belongs to same group 6, and how many bond pair of electrons? 2 bond pair of electrons. Sorry, how many lone pair of electrons? 6 lone pair of electrons. 1 2 3 4 5 6. How many bond pairs? 2 by 2. So is equal to 6 minus 6, which is equal to -1. So this oxygen bears a negative charge. Very good. And next oxygen O3. Now you calculate the formal charge for this third oxygen also. Number of valence electrons 6 and number of lone pair of electrons 6 minus bond pair of electrons 1 2 2 by 2, and also here it is -1. This oxygen will bear a negative charge. Okay, now calculate this formal charge for this sulfur. Here how many valence electrons? Belongs to same group, sulfur 6 valence electrons, minus how many lone pairs? 1, minus here 1 2 3 4 5 6 7 8. So how many bond pair of electrons are there around the sulfur? So 8 by 2, 4. Yeah, sorry. Here how many lone pair of electrons? 2 lone pair of electrons, and 2 lone pair of electrons around the sulfur 1 2 3 4 5 6 7 8. So here 4 minus 2, which is equal to 0. Clear? Okay. So here after calculating the formal charge, this is the Lewis dot structure. This is actually the way of writing Lewis dot structure for sulfite, which is derived from sulfurous acid. Okay. Okay. Next we'll discuss another example, that is SO4 2-. Okay. Now the next example is SO4 2 minus, I told you already, it is derived from sulfuric acid H2SO4. 2H plus SO4 2 minus. So, and it is sulfuric acid and it is sulfate. Okay, now as usually you calculate the number of valence electrons. Valence electrons is equal to how many lone pair of, what is the central atom? Sulfur is the central atom here. So how many valence electrons? 6 plus how many oxygens are there? 4. 4 into 6, which are 24. 24 plus 2. Because negative charge is there, no? You have to add to the valence electrons. So altogether 32 valence electrons. Okay, first step completed. And second step, write down the skeletal structure. Here 4 are there oxygens around the sulfur. You just put 4 oxygens and one bond for each sulfur. How to calculate? Second step, bond pair of electrons. 2 into number of bonds in the skeletal structure, which is equal to 2 into 4, which is equal to 8 electrons, bond pair of electrons. Okay. Next, third step here, valence electrons minus bond pair of electrons. Lone pair of electrons is equal to valence electrons minus bond pair of electrons, which is equal to 24. Now you start sharing these 24 electrons from the corner atom 1, 2, 3, 4th oxygen. So 24 electrons 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 fours are 24 here, and including the bond pairs for each and every oxygen octet has satisfied. Now what about sulfur? Here 2 minus is there. Sulfur exhibits a valency. It tries to be in maximum covalency. So now it want to share the pair of electrons from this oxygen and also from this oxygen, wherever it may. So here now what will be the structure? Here it is S double bond O, S double bond O, and write down the lone pair of electrons we left with 1, 2, 3, 4, 1, 2, 3, 4, and here oxygen with the lone pair 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now here around the sulfur 6 bonds are there. Very good. Now you calculate here where to keep these 2 minus negative charge. So here simply that oxygen with a double bond, there will not be any charge. So here oxygen with a, maybe this one and this one will bear a negative charge. We'll check that one by calculating the formal charge. Now 1, 2, 3, 4 and sulfur 5. Calculate the formal charge for all the atoms along with me. Calculate oxygen 1, number of valence electrons 6 minus number of lone pair of electrons 4, 1, 2, 3, 4. How many bond pairs? 1, 2, 3, 4. 4 by 2, which is equal to 0. Okay. Calculate the formal charge for the second one. Second one also number of valence electrons 6 minus how many lone pairs? 1, 2, 3, 4, 5, 6. Minus how many bond pairs? 1, 2. 2 by 2, which is equal to minus 1. I told you, no? Very good. And you calculate for O3, how many valence electrons? 6 minus how many lone pairs? 4 minus how many bond pairs? 1, 2, 3, 4. So it is 4 by 2, which is equal to 0. Okay. Now you calculate for this one O4. You calculate for this one O4, number of valence electrons 6 minus how many bond pairs, how many lone pairs are there? 6 valence electrons, 1, 2, 3, 4, 5, 6. 6 lone pairs are there, and how many bond pairs? 1, 2. 2 by 2. This is equal to here minus 1. This is the way of writing Lewis dot structure for SO for sulfate anion. Okay, clear? So here where to keep this negative charge? Just single bond O, there will be a negative charge. Double bond O, there will not be any charge. This is excellently useful while writing the exam. So you can confirm that by calculating the formal charge also. Okay. Then next we'll discuss another example, that is SO5 2 minus. Okay. Now another example is SO5 2 minus, which is derived from peroxysulfuric acid. What is a peroxy? Here peroxy means oxygen with an oxygen single bond. We call it as a peroxy linkage. Okay. Yeah. Now it is derived from H2SO5 peroxysulfuric acid, and this we call as peroxy sulfate. Peroxy sulfate. Now as usually, this is the central atom. Now same procedure for this one. How many valence electrons are there? Here sulfur belongs to 6th group, plus how many oxygens are there? Here 6 oxygen atoms are there. So 5 oxygen atoms are there. 6 valence electrons. So 5 into 6, which is equal to 30, and 2 minus plus 2. So which is equal to 38 valence electrons are there. 38 valence electrons are there. And now second step, writing the skeletal structure. So here S O O O O. Where to keep this another oxygen? I told you here oxygen is attached to another oxygen. This point you have to remember. And here how many bonds in the skeletal structure? Bond pair of electrons is equal to 2 into number of bonds, 1, 2, 3, 4, 5. So 2 into 5, which is equal to 10 bond pair of electrons. Next, third step, have lone pair of electrons. Lone pair of electrons is equal to valence electrons minus bond pair of electrons, which is 28. Now you start sharing these 28 lone pair of electrons starting from the corner atom. So 1, 2, 3, 4, 5, 6, 7, 8. Octet of this one satisfied. 1, 2, 3, 4, 5, 6, 7, 8 satisfied. 1, 2, 3, 4, 5, 6 satisfied. 7, 8 octet. 1, 2, 3, 4, 5, 6, 7, 8. This one also satisfied. 1, 2, 3, 4, 5, 6, 7, 8. This one also satisfied. Now how many we used? We have used all the lone pair of electrons, I think. 1, 2, 3, 4. 4, 6 are 24 plus 4, 28. Okay. Now here sulfur atom, here it tries to be in maximum covalency. So here 2 minus is there. Where to keep this negative charge? It want to be in maximum covalency, I told you. So here it will share, this oxygen will share a pair of this electron, and this oxygen will share a pair of this electron, and here these two corner terminal atoms. Now I told you, no, oxygen with a single bond will bear a negative charge. So here now we'll check that with a formal charge also by calculating. Now the structure, Lewis dot structure for this peroxy sulfate is SO O. It is double bond O, and here it is double bond O, and it is O. Now the lone pairs on this 1, 2, 3, 4. On this also 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Minus 1, minus 1. This is my assumption. You calculate the formal charge for each one. 1, 2, 3, 4, 5, 6. Sulfur also you calculate the formal charge. So first one, formal charge for oxygen, number of valence electrons 6 minus bond pair of electrons, here number of valence electrons. Now calculate the formal charge for the first oxygen, that is number of valence electrons minus lone pairs. 1, 2, 3, 4, 5, 6 lone pairs minus how many bond pairs? 1, 2. So 2 by 2, which is equal to minus 1. So oxygen with, I told you, no, oxygen with a single bond will definitely bear a negative charge. And next for the second oxygen you calculate, this is O2, number of valence electrons 6 minus lone pairs 4 minus bond pairs 4 by 2, which is equal to 0. Oxygen with a double bond, 0 formal charge. And O3, here oxygen with a single bond, definitely there will be a definitely you will get minus 1. Here 6 valence electron 6 minus lone pair 6 minus bond pairs 2, 2 by 2, which is equal to minus 1. Now oxygen, fourth oxygen. Now you calculate here, this is the fourth oxygen, number of valence electrons 6 minus number of lone pairs 4 minus bond pairs 4 by 2, which is equal to 0. Oxygen with a double bond, there will not be any charge. And O5, now you calculate this one. Here oxygen with a double bond, here this bond pair is there, another bond pair this side is there, so definitely the formal charge will be 0. Now you calculate the formal charge on O5, number of valence electrons 6 minus lone pairs 1, 2, 3, 4 minus how many bond pairs? 4 by 2, which is equal to 0. Okay, so these two will bear a negative charge. Now calculate the formal charge for sulphur. So here number of valence electrons 6 minus number of lone pairs 0 minus how many bond pairs? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 by 2, 0. Okay. By watching these three videos, you will definitely get a clear idea and you will be able to write any example on your own. Okay, I think this video is useful to you. So if you didn't watch those previous videos also, you watch those videos, then the topic will be very much clear to you. Okay, so if you want any particular topic or the unit, just write me in the comment section. So definitely I'll make a video on that particular topic or the unit. Okay, bye.